Hi, Assalamualaikum warahmatullahi wabarakatuh. Today I would like to present my progress report for this semester. Before I start, I would like to introduce myself first. My name is Nur Isatwente Anas Anisan. I'm a student in Doctor of Philosophy in School of Electrical Engineering at College Engineering in UiTM Shah Alam. My supervisor is Prof. Dr. Juliana Johari, TS Dr. Fazil Ahmad Uslan, Dr. Nufasi Abdul Razak, and Dr. Muhammad Azri. My project is entitled A Robot Operating System (ROS) for Vehicle-to-Vehicle V2V Motion Planning Algorithm. In this presentation, I will going deeply to writing paper for my submission, automation and robotics, and milestone or Gantt chart for the whole my journey study. Okay, this one is spread on progress work. I would have been done that I already went to site visit for my project. So I had designed control environment track for my robot, and I also collect data from GNSS or RGK. And I'm in currently on writing review paper and collect data for buggy localization, which is it is a filtered data from IMU, LiDAR, encoder, and RTK. For the future work, I will do an algorithm, which is we will using a FastIO and quick mapping from localization data, collect data for V2V, which is a form of mirror and signage such as stop sign. Then from the data, we will processing within V2V. And last one, I will submit the review paper. So right now, I was currently in collection data for localization. For this collection data, we need three input for localization and doing a mapping. So first one is IMU input, which is it measure the linear acceleration and rotational velocity and obtain 3D position of an object. Second, data from global navigation satellite system for time kinetic positioning accuracy within centimeters of the road. And the last one is LiDAR for determine the range and bearing of an object. So as you can see, if we get an IMU input and LiDAR input from this one, we will get to filter the data and do an odometry output. From the odometry output, we can do a mapping system. Okay, this one is for model predictive control. After we get the collection data and make it localization and mapping, so this one will be a prediction for the robot mapping. So as you can see, the robot is when the robot is moved, so we can see in simulation on how the route that robot will move, the prediction of the route that the robot will follow. So as you can see, the simulation will be like this. Success in making a mapping and localization for the robot, and the robot is success in autonomous. So then we will do a collaboration within V2V, which is within the robot or within the vehicle. So we will do a signage and tag for the robot to follow the path, and we will see whether the robot will follow. It is called a collaborative behavior automation, which is the robot will follow injectory that we put it in the robot, and when the robot stop detect the stop sign, it will stop and it will merge to follow the environment, and it will exit the mapping that we create. So it is the collaboration within V2V, vehicle to vehicle. So as the last part is Gantt chart, which is the planning for my whole journey study. So as you can see, we are in July. Right now we are on collection data and analysis of data. Then we will start it, process the data within the V2V. And I'm in currently on making a review paper and will submit on September. And I'm planning to finish my studies on a year from now, which is on August 2024. Alright, that's all from me. So thank you for lending me your ear in this presentation. Thank you.